Good afternoon to all. Today we are going to see about that is fifth topic in a database, that is file organizations and its types. Okay. Okay. In last class we discussed that is a normalization. So normalization is the process of organizing the data in a database, which is used to minimize the redundancy from the relations or set of the relations. Okay, so normalization is a process of organizing the data in a database, okay, which is used to minimize the redundancy from the relations or set of the relations. Okay, so and we discussed that its types, that is a normalization types, that is a first code normal form, second code normal form, and third code normal form, and next one is the Bayes code normal form, and then fourth one, and then last one is a fifth one. Okay, that is a Bayes code normal form. Okay, when you are using a first code normal form, okay, it has a no repeating groups. Okay, when you are using a second code normal form, so it has a no partial dependency, and also it is in a first normal form. Okay, when you are using a third normal form, so it is in a second normal form, and it has a no transitive dependency. Okay, when you are using a Bayes code normal form, that is indicating by the PZNF, so that is presented in a third normal form, and then so it is a stronger version of the third normal form. Okay, and then fifth normal form. So it has in a, a Bayes code normal form, and it has a no multi-value dependency. Okay, when you are using a fifth normal form, so it is in a fourth normal form, and it has a no join dependency. So these are the informations are we discussed in the last class. Okay, so today we are going to see about that is a file organizations. So the file organization is defined, that is a file organization defines how the file records are mapped on a disk blocks. Okay, so file organization is a method for arranging the record in a file. Okay, when the file is stored on the disk. So the file organization define how the files records are mapped on a disk blocks. Okay, that is a file organization is a method for arranging the record in a file when the files is stored on the disk. Okay, the file is organized logically as a sequence of the record. Okay, the file is organized logically as a sequence of the record. Okay, that record as the sequence of the fields. Okay, so there are two types of the record used in a file organizations. Okay, the file organization determines the set of the access of the method for storing and then retrieving the record from the file. Okay, the file organization is a method for arranging the record in a file when the file is stored on the disk. Okay, the file is organized the logically as a sequence of the record. So that record is the sequence of the field. Okay, so the file organization determines the set of and then retrieving the records from the file. Okay, there are two types of the record used in a file organizations, that is as a fixed length record and then variable length record. The first one is a fixed length record. The fixed length record, that is a file where the each record has same length or have a fixed length of the records. It's called as a fixed length. Some of the fields are always same. For example, if you are taking the phone number always that is a 10 character only. There is a 10 digits only. Okay, when you are taking the phone number, so that the some fields are always the same length. Okay, the best example is a phone number. When you are taking the phone number is always 10 characters. Okay, some fields are may need to be padded out, so they are correct length. Okay, some fields are always the same length. The example is our phone number. Our phone number should be a 10 digits. Okay, so the phone number is always a 10 characters. Some fields may need to be a padded out, so they are correct length. For example, if you are taking the employee records, okay, in that employee having an employee number, e-name, salary, and then phone number. Okay, so this is this field is may need to be padded out, so they are the correct length. Okay, the advantage of the fixed length record. what is the advantage of this fixed length recorders? The access is fast because the computers know where the each records start. Okay, the advantage of this fixed length recorders, the access is fast because the computers knows where the each record start. Okay, and what is the disadvantage? We seen the advantage, and what is the disadvantage of this fixed length record? Okay, due to the fixed size, some larger size record may cross the block boundaries. Okay, due to the fixed size, some larger size record may cross the block boundaries. That means that the part of the record will be stored in a one block, and other part of the record may be stored in a some other block. Thus, hence, we may acquire the two blocks of the access for each read and write. Okay, due to the fixed size, some larger size of the record may cross the block boundaries, which means that the record, okay, one part of the record will be stored in a one block, and other part of the record may be stored in a some other block. Hence, we require the two block of the access for the each record. That is for each read and write, or read or write. Okay, it is difficult to delete the record from this structure because this is a fixed size, so that it is difficult to delete the record from this structure. If some intermediate record is deleted from the file, then the vacant space must be occupied by the next subsequent records. Because if some intermediate record is deleted from the file, then the vacant space must be occupied by a next subsequent records. Okay, is it clear now? It is difficult to delete the record from this structure because this is a fixed length. If some intermediate record is deleted from the file, then the vacant space must be occupied by the next subsequent records. When the record is deleted, we can move the record so that came after it into the space formerly occupied by the deleted record. But this may require the moving of the multiple records to occupy the vacant space. This is the undesirable solution to fill up the vacant space of the deleted records. Okay, so is it clear now? So another approach is to use the file header. At the beginning of the file, we allocate the certain number of the bytes as the file header. Okay, this is another approach. Okay, used to file header. So to use a file header, at the beginning of the file, we allocate a certain number of the bytes as a file header. The header will contain the information such as the address of the first record whose contents are deleted. Okay, the header will contain the information that is such as the address of the first record whose contents are deleted. Okay, we use this first record to store the address of the second, the available record, and so on. Thus, the stored record address are referred as the pointer, while the deleted records, okay, thus from the linked list, which is called as a free list. Okay, so these are the disadvantages of there in a fixed length record. Okay, for example, if you are inserting a new record, okay, on insertion of the new record, we use the record pointer by the header. Okay, we change the header pointer to the point to the next available record. If there is no space, we add a new record to the end of the file. Okay, when you are inserting the new record, we use the record pointer by the header. Okay, we change the header pointer to the point to the next available record. If there is no space, we add a new record to the end of the files. Okay. So next, let us see about the variable length record. So variable length means that is the record arrays in the database in several ways. The storage of the multiple records type in a file. Okay, storage of the multiple record types in a file. The record types that allow the variable length for one or more fields. Okay, the record types that allow the variable length for one or more fields. Okay, the record types that allow the repeating fields such as the array or multi-sets. Okay, the representation of the record with the variable length attributes typically has a two part. First one is the initial part with fixed length attribute. So this initial part of the record is represented by the pad, that is offset or length. The offset denotes the starting address of the record, while the length represents the actual length of the length. And then second one is followed by the data for the variable length attributes. Okay, if you are taking the employee table, okay, so in that employee table having an employee number, employee name, and then salary, so and then phone number, these are the fields are there in the employee table. So in the table we are using variable length, that is a variable length representations of the first record. Okay, the variable length record can store in a blocks. Okay, next let's see about types of the file organization. So we study the three types of the file organization. The first one is the unordered or heap files. Okay, first one is the unordered or heap files, and then second one is the ordered or sequential file. Okay, and third one is the hash file. So here we are going to see three types of the file organization, that is unordered or heap files. Second one is ordered or sequential files, and third one is the hash files. Here we examine each of them in the terms of the operation we perform on the database, that is insert a new record and search for the record, that is update our record and then delete the record. So these three operations are done in that types of the organization. The first type is a heap. If you are taking the unordered or heap, that also we can use these operations, that is a insert, delete, and then search. Okay, if you are using a sequential files, okay, so there also we are going to do these operations, that is a insert, search, and then delete. If you are using that is a hash files, there also we perform these operations, that is a insert, search, delete. Okay, so is it clear now? Okay, first let's see about the heap, that is unordered. Okay, heap or unordered. Okay, first let us see about the heap, that is a record can be placed anywhere in the file, so where there is a space. Okay, the meaning is record can be placed, your record can be placed anywhere in the file where there is a space. Okay, and then any record can be placed anywhere in the file where there is a space. So there is no ordering for the placing the record in the file, which means that the record can be placed anywhere in the file where there is a space, which means that there is no ordering for the placing the record in a file. So generally the single file is used. Okay, and then sequential, store the record in a sequential order. Sequential means that is a ordering the file. The store the record in a sequential order based on the value of the search key of the each record. The records are stored in a sequential order based on the value for the search key. Here we are going to use the search key in a sequential order. Okay, based on the search key we can do the operations. Okay, and then hashing. The hashing, this is a function computed on the some attribute of the each record. Okay, the term the hash indicating the splitting of the key into the pieces. The records of the each relations may be stored in a separate file. So the hash indicates the splitting of the key. So here also we are going to use the key. So that key can be splitted into the pieces. Okay, the records of the each relations may be stored in a separated file. Okay, so the hash function is used to obtain the locations of the record in a file. Based on the value written by the hash function, the record is stored in a file. Okay, So this is a function. The hashing is a function. It's computed on the some attribute of the each record. The hash indicates the splitting of the key into the pieces. Okay. The records of the each relations may store in a separated file. So the hash function is used to obtain the locations of the record in a file. So based on the value returned by the hash function, the record is stored in a file. Okay. So here next see about the unsorted, that's a heap file. So the records are stored in the same order in which they are created, which means that records are stored in the same order in which they are created. Okay. Okay, here also we can perform the three operations, right? Already told you know in the previous slide we saw. Okay, that is three operations is there. That is insert, search, delete. Okay, here also we can do that operations. Okay, that is a insert operation in a unordered or heap files. Okay, so when you are doing the insert operation, so that is fast. The insert is a fast because the incoming record is written at the end of the last page of the file. Okay, so how it's faster? Because the incoming record is written at the end of the last page of the file, so that the insertion is fast here. And next do the search operation. The search operation is slow because the linear search is performed on this page. The linear is so searching one by one. When you are using a binary, we can find out the midpoint. After that we can split into the two part. First we have to find out the higher, and then next we have to find out the lower level. So in this way, so that can be executed. Okay, so here we are using the linear search so that it can search by line. Okay, so that is the searching operation is slow. Okay, and we can do the delete operations. Delete operations also slow because the record to be deleted as first searched. Okay, the record as deleted to be deleted as the first searched. Okay, the deleting record create the hole in the page. Okay, when you are using a heap, the heap meaning the records are stored in the same order in which they are created. Okay, here also we can do these operation, that is a insert operation, search operation, and then delete operations. When you are doing the insert operation, that is a fast. Okay, because the incoming records are written at the end of the last page of the file. Okay, and then when you are doing the search, that is slow because we are using the linear search in this heap files. Okay, when you are doing the delete, that also slow because the record to be deleted is the first searched, so that the time was slow. Okay, and then the deleting record create a hole in the page. Okay, next let us see about that is order or sequential file. The records are stored on the value of the one or more fields. The records are stored on the values of the one or more fields. The sequential, that is a sequential file organization. The sequential file organization is a simple file organization method in which the records are stored based on the search key value. Already told you know, when you are using a search, that is based on the search key value. Okay, so here also we can do so that operation, that is a search, delete, insert. When you are doing the search, that is a fast because here we are going to use the binary search. Okay, in a unordered pad, that is we are using the linear search in an ordered file using the binary search, so that the searching is a fast here. Okay, when compared to the unordered. Okay, when compared to the unordered, this ordered pad is fast than the unordered file. Okay, and then delete operations also fast when compared to the unordered. Okay, because the searching is a record is fast. The searching, because the searching the record is a fast. So this operations also is a fast when compared to the unordered, that is a heap. Okay, And next do the insert operation. This operation is a poor than the unordered pair, because if we insert the new record in the correct position, we need to shift more than the half subsequent of the record in a file. Okay, because this is a sequential file. Okay, that one is a heap file, so we can store the file anywhere in a file. Okay, where that space is available. Okay, when you are using a heap, you can store the file in anywhere. Okay, where the space is available. Here we are using a sequential file, so that the insert operation is poor than the unordered file. Okay, that's a poor, because if we insert the new record in the correct position, we need to shift more than the half subsequent record in a file. Alternatively, the overflow files is created, which contains all the new record as a heap. The periodically overflow file is merged with the main file. Okay, when compared to the unordered and then ordered, the insertion is a poor than the unordered file. Okay, and then when you're doing the search in this, that is a sequential file, that is a fast than the unordered file. Okay, that is a heap file. When you're doing the delete operation here, that is a fast than a unordered file. Okay, so this is a comparisons of the sequential and then random. The random is unordered, sequential is ordered. Okay, so this figure shows that comparison. Okay, this is example of the sequential access and then random access. The sequential access means that the group of the element has accessed predetermined order sequence. Okay, the random access file will be splitted into the pieces and will be stored wherever the space is available. The sequential means that is ordered. Okay, so one after another. Okay, in a random, when you store the file, okay, when you store the data in a file, so that is split into the pieces, will be stored wherever the space is available. That is the main difference. When you are using a sequence, that file is stored in a order one by one. Okay, when you are using a random, that is unordered. Okay, the file will be stored, okay, wherever the space is available. Okay, then the sequential file may load the faster than the random access file. The sequential file is, it's may load faster than a random access, because its files may take a time when you are using a random access, because that file is stored any places. Okay, so that when you're taking that file, it takes some time. Okay, then only retrieve the data from the file. Okay, when you're using a sequence, that is the order of the file, so that the less time. Okay, when you're taking that file, it may take a less time. When you're using a random, that file may take a more time when compared to the sequential. The sequential means that is a order of the file. Random means that is a unordered pair. Okay, the sequential file may load the faster than a random access. Okay, and next let's see about the other type, that is a hash file. So still we discussed that is two types. One is unordered, that is a heap, and then second one is a sequential, and third type is a hash files. Okay, is the array of the buckets. So what is my bucket? So the bucket is a unit of the storage containing the one or more records. The bucket is typically the disk of the block. That's a disk block. Okay, the bucket is a unit of the storage containing the one or more records. It's called as a bucket. Okay, here we are going to use that bucket. Okay, and then hash function is used to locate the record for access, insertion, as well as the deletion. So here also we can perform that three operations, that is insert, search, and then deletion. Okay, hash function used to locate the record for access, insertion, as well as deletions. Okay, the hashing is effective technique to calculate the direct locations of the data record on the disk without using the index structure. Okay, so the bucket here, when you're using a hash function, hash file, so that is using a bucket. So bucket is a unit of the storage containing the one or more records. The bucket is typically called as a disk block. Okay, the hash function is used to locate the record for access, insertion as well as a deletion. Okay, hashing is an effective technique to calculate the direct locations of the data record on the disk without using a index structure. Okay, given the record, K has a function, hash function. Okay, given the record, K is a hash function, so that h of K compute the index of the bucket in which records K belongs. Okay, here given the record K is a hash function, so we return h of K. So compute the index of the bucket in which records K belongs. Okay, the h uses one or more fields in the record called hash field. So h is a hash function. So h is indicating that is a hash function. So k is a record. Okay, given the record k has a hash function, and so that is written by h of k and compute the index of the bucket in which records k belongs. Okay, and h use one or more fields in a record called a hash field. And here also we are going to use the one key they named as hash key. Okay, the key of the file when it is used by the hash function. So that hash function written by h of k is equal to k mod m. So in this way this hash function can be written. Okay. The organization of the records in a files has a three types. One is a heap file organization, that is unordered, okay, and then ordered, that is a sequential, and third one is a hashing. Okay, so in the hashing here we are seeing that hashing file. So hashing file using the bucket, that is the array of the bucket. So array of the bucket, the array is a collection of the similar data items, and the bucket is the unit of the storage containing the one or more records. Okay, and typically it's called as a disk. The hash function is used to locate the record. The hash function is that is h, and then k is a record. So the hash function can be written the h of k and compute the index of the bucket in which records k belongs. Okay, the h uses the one or more fields in the records called hash field, and here also we are going to use the hash key, the named as the key of the files when it is used by the hash function. That hash function can be written as h of k is equal to k mod m. Okay, here also we perform the three operations, that is the insert operation, search operation, and delete operations. Okay, when you are doing the insert operation, that is a fast. Okay, because the hash function compute the index of the bucket to which the record belongs to. Okay, with which the records belongs. Okay, if the bucket is full, you go to the next free one. Okay, so when you are doing the insertion, that is fast because the hash function compute the index of the bucket to which the records belongs. Okay, if that bucket is full, you can go to the next free one. The bucket is a disk. Okay, and then next do the search operation. The search operation is also fast. Okay, because the hash functions compute the index of the bucket. Okay, so the search operations are also fast because the hash function compute the index of the bucket. And next, let's see the delete operation. We can do the delete operations here in a hash function. That is that also fast because the once again for the same reason for the hashing function being able to locate the record quick. Okay, so delete operations also fast. Okay, when compared to the these two, that is sequential and then heap. So this is highest, that is, this is the, I mean, fast, then that heap, and then sequential. Okay, here the insertion is also fast, and the searching also fast, and then delete also fast when compared to the heap and then sequential. Okay, and next what to say about the indexing. So what is my indexing? Why we are using indexing here? So you are going to store the data in a database. Okay, for that we are using the indexing. Okay, you are storing data. Okay, in a file. How to take on data. The data will be stored in a database. So for storing our data, we can give a number. Okay, so that is a indexing number. So that we are using the indexing here. So the index is a data structure that is organized the data record on the disk, because the disk is a server or any a storage device. Okay, so in that storage device you have to store the data in that device. Okay, so for that we are using the indexing. The indexing is a data structure that is organizing the data on the disk to make a retrieval of the data efficient. Okay, so indexing, that is a data structure that organizes the data on the disk to make a retrieval of the data efficient. And here also using the searching key for indexing. For the indexing is the collection of one or more fields of the record using which we can efficiently retrieve the data that satisfy the search conditions. Okay, the search key for index is collections of one or more fields of the record using and which we can efficiently retrieve the data that satisfy the search conditions. Okay, the indexes are required to speed up the search operations on the files of the record. There are two types of the indices. The one is ordered index and then hash index. Okay, when you are using ordered indices, okay, that is the primary index of the clustering index. So the order means that is a primary index or clustering index, which is used to access the data sorted by the order of the value. Okay, so indexing is a data structure that organizes the data records on the disk to make a retrieval of the data efficient. So that we are using the indexing here. Okay, based on by using this index, we can arranging the record on the disk. They are organizing the data record on the disk to make the retrieval of the data efficient. Okay, so this index can be divided into two parts, that is ordered and then hash index. The order means that is a primary index of the index or a clustering index, which is used to access the data sorted by the order of the values. And then next type is the hash index. So that is a secondary index or non-clustering. The first one is the order index, that is a primary index or a clustering index. When you are using a hash index, that is a secondary index in a clustering index. Secondary index or clustering index in a file. Okay, which is used to access the data that is distributed uniformly across the range of the bucket. Okay, which means that this is type of the index based on the uniform distributions of the value across the range of the buckets. Okay, the address of the bucket is obtained using the hash function. Okay, there are several techniques for using the indexing and then hashing. So these are the techniques are evaluated based on the following factors, that is accessing time, accessing types, insertion time, deletion time, and space overhead. Okay, when you are using the access type, it support the various type of the access that are supported efficiently. Okay, when you are using the accessing time in this indexing, okay, it's denote the time it's take to find the particular data items for set the items. Okay, so when you are using accessing time, it's denote the time it's take to find the particular data items or set items. Okay, when you are using insertion time, okay, it's represent the time required to insert the new data items. Okay, when you're using a deletion times, it's represent the time required to delete the desired data items. Okay, when you're using a space overhead, so the space is required to occupy the index structure, but allocating such extra space is work to achieve the improved performance. Okay, these are the techniques are used in this indexing. Okay, so the techniques are access type, access time, insertion, deletion, and a space overhead. So these are the techniques are used in this indexing. Okay. And next, let's see that is a primary index, cluster index, and secondary index. So when you're using a primary index, that index built on ordering the key field of the file. So this is the important one. So based on this, they will ask the questions in the exam. Okay. So this is the important one. Okay. When you're using a primary index, when they're asking the primary index, that is index built on ordering the key field of the file. Okay. So the index built on the ordering the key field of the file. Okay. Next one is a clustering index. This clustering index built on ordering the non-key field of the file. Okay. When you are using a primary index built on the ordering the key field of the file, that is the ordering. Primary means that is ordering. Okay. When you are using clustering index, that is ordering but non-key field of the file. Okay. And when you're using a secondary index, okay, the index built on any non-ordering field of the file. Okay, you know the difference. When you're using a primary index, the built on the ordering key field of the file. When you're using clustering index, the built on the ordering non-key field of the file. Okay, when you're using a secondary index, that is built on any non-ordering field of the file. Okay, so please keep it in mind. This is an important one. Okay. And next, let's say about B-tree index. Okay, this is one of the index. Okay, so B-tree is the most commonly used the data structure for indexing. Okay, the B-tree is the most commonly used the data structure for indexing. It is a fully dynamic. Okay, it's not a static. Static means that is a constant. Okay, it is a fully dynamic. It is a variable. So that is, it can grow and shrink because it is a dynamic, you know, so that it can grow and shrink. Okay, so the three types of the B-tree nodes. So the first one is a root node, branch node, and then leaf node. So there is a three types of the B-tree node. So B-tree is the most commonly used the data structure for indexing. So that we discussed here. Okay, the B-tree is one of the indexing data structure. Okay, it is a fully dynamic, so that it can grow and shrink. Okay, if it is suppose if it is static, once it can grow means you can't do anything on that. Okay, so that it is a dynamic, so that is it can grow and shrink. Okay, next let's see that three types of the B-tree node. The first node is a root node. That root node contains the node pointer to the branch node. Okay, in a root node contains a node pointers to branch nodes. Okay, and then branch node contains the pointer to the leaf nodes or other branch nodes. Root node contains the node pointer to the branch node. In a branch node contains the pointers to the leaf node or other branch node. Okay, and the leaf node contains the index items and then horizontal pointers to the other leaf nodes. Okay, in a root node contains the node pointers to the branch node. In a branch node contains that is a pointers to the leaf node. In a leaf node contains the index items and then horizontal pointers to the other leaf nodes. Okay, is clear now? Okay, let's move. So this is the example of the B-tree structure. Okay, so here the first one is a root node, and then the second one is a branch node, and then leaf node. So this figure shows that the structure of the B-tree. Okay, so how they interlinked. That is a root node and a branch node and a leaf node. Okay, this is the index items. Okay, so in a leaf node we have to insert the value. Okay, next let's see the another slide. That is a B-tree. That is a dynamic multi-value indexing are implemented as a B-tree and then often as a B+tree. Okay, next let's say about the B+tree, and next discuss the comparisons of the B-tree and then B+tree and which one is the best when compared to these. Okay, so that is when you are using a B-tree, allows the indexing field value to appear only once at the some level in a tree. Okay, when you are using a B tree, allows the indexing field value to appear only once at some level in a tree. Okay, the pointer to the data at the each node. Okay, the pointer to the data at each node. When you are using a B plus tree, okay, the B plus tree is a updations of the B tree. Okay, so the pointer to the data are stored only at the leaf node of the tree. Okay, the pointers to the data are stored only at the leaf node of the tree. Okay, the leaf node have a entry for the every indexing field value. Okay, so the leaf node the leaf nodes are usually linked together to provide the ordered data access on the indexing field to the records. That is, the leaf nodes are usually linked together to provide the ordered data access on indexing field to the records. All the leaf nodes of the tree are at the same depth, so that the retrieve of the any record takes the same times. Okay, so all the leaf nodes of the tree are at the same depth, which means that the retrieve of the data, okay, the retrieve of the any record takes the same time. Okay. Okay, next let us see about the comparisons of the B tree and then B plus tree. So it can be so that is a B plus tree versus B tree versus B plus. Okay, in a B tree, search key and the data stored in a internal or leaf nodes. In a B tree, the search key and the data are stored in internal or leaf node. Whereas the B plus tree, the data are stored only the leaf node. In a B tree, the search key and the data are stored in internal or leaf node. Okay, whereas the B plus tree, the data are stored only the leaf node. Okay, and the searching of the data in B plus tree is very less. Okay, the searching, we can do the searching in a B plus tree. The searching of the any data in a B plus tree is very easy because all the data are stored in a leaf node, because that is the data are stored only the leaf node, you know. So that the searching also very easy when compared to the B tree. Okay, when compared to the B tree, the searching operation is very easy in the B plus tree, because all the data are found in a leaf node. Otherwise, in B tree, the data cannot found in a leaf node because the data stored in an internal or leaf node. Okay, they given the data are stored in internal or leaf node, so that the B tree is in a B tree, the searching is fast than a B tree. B plus trees in a B plus tree is searching, that is searching operation is faster than a B tree. Okay, in a B tree, the data may found the leaf or non-leaf node. The deletion of the non-leaf node is very complicated because the data stored in an internal or leaf node, so that the data deletion of the non-leaf node is very complicated when you are using a B tree. When you are using a B plus tree, the data must found a leaf node because the data store only the leaf node, you know. So that the deletion is also very easy when compared to the B tree. So in a B plus tree, the data deletion is also fast than a B tree. So the B tree is so B tree is the best than a B. Okay. Otherwise, the B plus tree data must have found the leaf node. So the deletion is easy in a leaf node because the data store only the leaf node in a B plus tree. The insertion of the B tree is more complicated than a B plus tree. So deletions are also complicated when you are using a B tree, and insertion deletions also complicated when you are using a B tree. B plus is a concept of the overcome. That is the implementation of the B plus is the implementation of the B. Okay, so that B tree data may found the leaf or non-leaf node. The deletion of the non-leaf node is very complicated. Otherwise, in a B plus tree, data must found the leaf node. So the deletion is easy in a leaf node because the data store only the leaf node. The B plus tree store the redundant search key, but in the B tree has a no redundant. Redundant means that is a repeating. Okay, when you are using a B plus, store the redundant search key. But when you are using a B tree, has a no redundant value. In a B tree, leaf node data are ordered in a sequential linked list. When you are using a B plus tree, the leaf node data are ordered in a sequential linked list. Whereas the B tree, the leaf node cannot store the using a linked list. The many database system implementer prefer the structural simplicity of the B plus tree because that is B plus tree is the implementation of B tree. So that when you are doing that operation, that is the insertion operation, deletion operation is best than a B tree. That is a implementation of the B. Okay. This is an example of the B plus tree and then B tree. So this is a structure of the B tree and then B plus tree. Okay, next let's see the gate questions. So based on this concept, okay, so we see that gate questions, how they are asked. Okay, the following questions has been asked in the previous gate exam. So the first question is, before going to see this question, first one times we recall, okay, that is in first in file organization we discussed, okay, we discussed that is what is meant by file organization and what are the records, what types of the record, okay. So that is a fixed length record and then variable length record, and file organization type is unordered and order and hash files. And next one is we can see that I mean operations, what are the operations are done in that I mean types of the file organization, that is unordered and heap files and order and sequential files and hash file. So when you are taking the heap files, that also we can perform that insert search and delete operations, okay. And also the when you are taking the sequential file, so there also we can perform that insert search and delete operations. And if you are taking the hash files also, there we can perform that insert search and delete operations, okay. So the concept of the heap is that is, you can record, the record can be placed anywhere in the file where there is a space, okay. And then sequential is store the record in a sequential order based on the value of the search key of the each records. And hashing is a function computed on some attributes of the each records. The hash indicating the splitting of the key into the spaces, okay. The record of the each relations may store in a separated file, okay. So compared to these the heap and sequential, hashing is the best one, and this hashing is the best one and compared to the heap and then sequential, okay. And let's see the indexing file. So indexing is why we're using indexing means that is a data structure that organizes the data record on the disk to make a retrieval of the data efficient, okay. So the search key for index is collection of one or more fields of the record using which we can efficiently retrieve the data that satisfy the search conditions, okay. So here also we are there are two types of the indexes, that is order and hash indexes. Order is a primary and then hash index is a secondary, okay. In the primary indexes, that is ordering the key field, that is a clustering index, that the ordering non-key field. The secondary index is any non-ordering fields. And next let's see about the B tree, and B tree is that is it's a data structure for indexing, okay. It is a fully dynamic and that is it can grow and then sting. So here also the three types of the B3 nodes, and the root node, branch node, and the leaf node. And if you are using a B plus tree, that is implementation of the B tree, okay. The B tree is I mean best when compared to the B tree because the B plus tree is that is data are stored only the leaf node, so that the insertion deletions are the deletions can be fast when compared to the B tree. That is implementation. Okay, B plus tree is the implementation of the B tree. Okay, this is a structure of the B plus tree and then B tree. So let's see the gate questions, what they ask and how they asked in the exam. Okay, and the following questions are asked in the previous gate exam. The first question is the disk seek takes the 4 microseconds. That the disk data transfer, the bandwidth is 300 MP per seconds, and the checking the tuple to see if the amount is greater than the x. That takes the 10 microseconds. Which of the following statement is correct? The question is, a disk takes the 4 ms and disk data transfer bandwidth is 300 MP per second, and the checking a tuple to see if the amount is greater than x and take a 10 microseconds. Which of the following statement is correct? Okay, here they given the two table, so named as courses and then enrolled. Okay, the options is the plan 1 and 2 will not output identical row sets for all the database. The option A, the plan 1 and 2 will not output identical row sets for all the database. And then option B, the course may be listed more than the ones in output of the plan 1 for some database. Okay, the option B, the course may be listed more than once in the output of the plan 1 for some database. Option C, the for x is equal to 5000, the plan 1 execute faster than the plan 2 for the all the database. The option C, for x is equal to 5000, the plan 1 executes faster than the plan 2 for all the database. And then option D, for x is equal to 9000, the plan 1 executes slower than plan 2 for the all the database. Our correct answer is C, because the assuming the large enough memory is available for all the data needed. Okay, assuming that the large enough memory is available for all the data needed. The both plans need to load up both tables, that is a course and enrolled tables. So the disk access the time is same for the both plans. Both plans need to load up both tables, course and then enrolled. So here they given the two table named as course and enrolled. Okay, so the disk access the time is same for both plans. That is a plan 1 and then plan 2. Okay, in the plan 2 does lesser number of the comparisons compared to the plan 1. The plan 2 does the lesser number of the comparisons compared to the plan 1. Okay, and then the join operations will require the more comparisons, as the second table will have a more rows in the plan 2 compared to the plan 1. The join operations will require more comparisons, as the second table will have a more rows in the plan 2 compared to the plan 1. The joint table of the two tables will have a more rows, and so more comparisons are needed to find amongst the greatest than x. Okay, the find amount the greater than x. So that the option C is correct answer. Okay, next question is, which of the following is correct? Okay, the options are option A, the B tree are storing the data on a disk, and the B plus trees are for main memory. And then second option, the range queries are faster on a B plus tree. And then C, the B tree for primary indexes and B plus trees are secondary indexes. So, and then option D, the highest of the B plus tree is independent of the number of the records. So look at the first option, B trees are storing the data on the disk and B plus trees are main memory. It is a wrong answer. because the B plus tree and then B trees both are stored the record in a leaf node. In a B trees are stored in a leaf node or any other internal devices, but the B plus trees store the data in a leaf node only. So that the first option is false. Okay, and then second option, that is a range of queries are faster on a B plus tree. So when compared to the B plus is a faster than a B. Okay, the B plus tree is faster than a B. Okay, B tree. Okay, so that the B is the correct one. And let's see the third option. The B trees are for primary indexes and B plus trees are secondary indexes. Our question is, so which one is the following? Which of the following is correct? Okay, when you are using a B tree, that is a secondary, and B plus tree is a primary. Okay, so this option is also wrong. Okay, and look at the fourth option, that is a height of the B plus tree is independent of the number of the records. So this option is also, that is a false. So height of the B plus tree is independent of the number of the records. That is a dependent. Okay. So that the answer is the B, that is arrange the queries are faster on a B plus tree. Okay. And let's see the other question, that is the next question. And consider the B plus tree in which the search key is 12 bytes long and the block size is 1024 bytes long. That 24 bytes, and record pointer is 10 bytes long and the block pointer is 8 bytes long. The maximum number of the key that can be accommodated in each non-leaf node of the tree is. Okay, the consider our question is consider the B plus tree in which the search key is 12 bytes long and the block size is 1024 bytes. That is a storage device. Okay, storage device size is 1024 and then the search key is 12 bytes long. Okay, and then the pointer, record pointer is 10 bytes long. The block pointer is 8 bytes long. Okay, so the maximum number of the key that can be accommodated in each non-leaf node of the tree is, so the given the answer, given the options are 49, 50 and 51 and then 52. The correct answer is 50 because the let the m be a order of the B plus tree, the m of 8, okay, plus m minus 1 of 12 less than or equal to 1024. Note that the record pointer is not needed in non-leaf nodes. Note that the record pointer is not needed in the non-leaf node, so that the m less than or equal to 51. Since the maximum order is 51, the maximum number of the key is 50. So that the answer is 50. Okay. So because they are asking the maximum number of the key that can be accommodated in each non-leaf of the tree. Okay. So that the note that the record pointer is not needed in a non-leaf node. So the m less than or equal to 51. Since the maximum order is 51, right? The maximum number of the key is 50. The maximum order is 51. So that the maximum number of the keys is 50. Okay, next we'll see the question. Which of the following statement is not correct about the B plus tree data structure used for creating the index of the relational database table? So the question is, which of the following statement is not correct about the B plus tree data structure used for creating the index of the relational database table? So look at the options. The options are B plus tree is the highest balanced tree. Okay, which one is the not correct about the B plus tree data structure, right? B plus tree is the highest balanced tree. It's a true. Okay, and look at the second option, that is a non-leaf node have a pointer to the data records. Non-leaf node have a pointers to the data records. It's a correct one. I mean, this is a not correct. That is a, which means that the B plus tree non-leaf node have a pointers to the next level node, but not to the data records. So is it clear now? In the B plus tree, non-leaf node have a pointers, right? Non-leaf, the B plus tree, non-leaf node have a pointer to the next level nodes, but then not to the data records. So that the option B is Wrong one. Look at the third option, that is C. Each leaf node has a pointer to the next leaf node. That is also correct, because the data is stored only the leaf node, so that each node has a pointer to the next leaf node. Okay, and look at the last options, that is key values in each nodes are kept in a sorted order. So the key values in each nodes are kept in a sorted order only. So that answer also correct. Our question is which one of the following statement is not correct about the B plus tree data structure. So that option B is not correct. Okay, that is answer is B options. That statement is not correct about the B plus tree data structure. And let's see the question. Let us consider the B plus tree in which maximum number of the key is in the node is 5. What is the minimum number of the key in any non-root node? Consider the B plus tree in which the maximum number of the key in a node is 5. And what is the minimum number of the key in any non-root node? The answer is 2, because the maximum number of the key in a node is 5, So that the minimum number of the key in any non-root node. They are asking what is the minimum number of the key in any non-root node. Okay, so minimum number of the key. The maximum number is 5, so that the minimum number is 2. Okay, next question. The file is organized so that the ordering of the data record is the same as or the close to the ordering of the data entry in some index. Then that index is called what? The file is organized. The file is organized so that the ordering of the data record is the same as or the close to the ordering of the data entry in a some index. Then that index is called as a what? Is it a dense or is it a sparse or a cluster or unclustered? It is called as a cluster because the file is organized so that the ordering of the data, the order means that is a cluster. Okay, the ordering of the data records is the same as or close to the ordering of the data entry in a some index is called as a cluster. So that the answer is a cluster. The option C is the correct one. Okay, any doubt so far? Any doubt, please ask me now. Okay, thank you.